Okay, so DFS of course can be also done in directed graph, and we can also do this pre-post numbering. The code modification is very similar. We have a time counter that we define, and then we increase the time counter when we enter a vertex, and we mark it as pre-time for this vertex, and when we leave, we mark the post time with this counter increase. So it's all same old, same old. And now, you can run DFS on a directed graph, and you get these numberings. And I'm not going to do the DFS again one by one. If you run it on this graph, you get this graph where, again, for every vertex, I wrote the time interval when it's active, right? So the pre-post numbering for this interval. Okay. And there are interesting creatures in this directed graph because we have the three edges. Now they are directed edges. And then we have the edges that are not in the tree. And let me show you, there are edges that go forward, backward, and cross edges. So let's talk a little bit about this different type of edges. But let's first do some basic properties of DFS before we go into this edges properties. So again, it's easy to verify that the running time is linear because every edge is getting inspected once. The computed tree now is called a branching because it's essentially a forest of directed trees. And of course, the output of the DFS is not unique. It depends on the order in which the vertices are being inspected and the edges are being inspected. And importantly, of course, is that the first vertex being visited by the DFS, the rooted tree that the DFS compute is, of course, all the vertices it can reach, right? So all the reachable vertices are in this rooted tree. So this is one way of computing the reachable set, as we already mentioned. And again, one can prove the same property we had seen before, that two time intervals are either disjoint or contained inside each other. Okay. And of course, DFS would turn out to be quite useful in directed graph. Now, as I mentioned earlier, there are a lot of interesting edges when you speak about DFS in directed edge. So of course, there are the red edges, which are the DFS edges. We have forward edge, which is an edge that goes from an ancestor to a descendant. To remind you, this was the only kind of edges that we got not in the DFS tree in the undirected case. Now we have backward edges. Those are just edges that go from a descendant to the ancestor. And we have cross edges. Right, cross edge essentially means that C was visited before D was visited, right? Because if D was visited first, then the DFS would, of course, token the cross edge and add it to the DFS. So we can get cross edges. Of course, in undirected graph, we cannot get it because we cannot have cross edge because once we visited C, we'd always explore this edge if we're in undirected graph. Okay, so those are the four kind of edges. And the nice thing is that an edge, we can immediately decide what the type of the edge is by looking on the time intervals, okay? So a tree interval, we just know it's in the tree interval, right? Because we know it, we know it's in the DFS tree and we mark it as such. Okay, a forward edge is just an edge such the interval of its x going to y, in all those things, it's just an edge where the time interval for y is contained inside the time interval for x. Right. Backward edge is just an edge where it's an edge which is not in the tree, right? Where again the time interval of y is contained inside the time interval of x. Right? So right, okay. Now, you have to notice that the important thing here is that x and y flipped here. So it's not, although this looks the same, it's not the same, right? So, and this is an edge that goes from now y to x, okay, where the time interval of y is contained inside the time interval of x, right? So this is kind of unfortunate a bit, but this is a backward edge, right? Okay, and a cross edge is just an edge where the two time intervals are disjoint. So those are the three types. And the nice thing is that we can detect all those types by just looking on their time intervals, except for the three edges, which we just need to mark them as being in the DFS tree, which the DFS process, of course, can do. Okay, so here's the tree. Let's look on the kind of edges we have here. So this is a cross edge. This is a backward edge. This is a cross. So maybe I should use different colors. Let's use different colors. Okay. Purple would be, this is a backward edge, right? And here's another backward edge. So those are the two backward edges. Let's do the cross edges. So this is a cross edge. This is a cross edge. This is a cross edge. And finally, let's do the forward edges. So I think there is only one forward edge, which is this edge. Okay, so those are the different kind of edges that appear in the DFS of the directed graph. Okay, this is it for now.